Hello guys, welcome back to my channel, Ekene Canada Knowledge Quest. As you know, our channel is for an educational channel and helps solves mathematics and engineering problems. So today we're going to continue on our integration by parts. In our previous video, we're able to establish the general formula for solving questions on integration by parts. And now we have some questions for us to solve. But before attempting any integration by parts questions, there's some basic things you need to know. For example, we need to know something we call the light, the order of taking your, for example, if we have the general formula we proved the other day, integral u, the v equal to uv minus integral v du. So this is our general formula. So we want to know which one we can make as a u and which one we can make as a v, because it's very important so that it doesn't confuse us. So for L, the first one is called the logarithmic functions, Then this is the inverse trigonometric functions. Logarithmic functions, we will have lim x, Example are the natural log. Then inverse trigonometric functions, example we have the arc tan of a function. Then this is one we call the algebraic functions. For example, have the x squared, Then our t is a trigonometric functions. For example, we have the sine of a function. Then the last one is the exponential functions. For example, e exponent x. So what this thing means that when giving an integral function to a function to integrate, you have to look which one comes first. Do we have the logarithmic function first? If we have anywhere with the logarithmic function, we'll take it as our u. Then in this order, so anywhere we see the trigonometric and the logarithmic function, we have to prioritize this one and make it our u. Then the trigonometric function our dv. Now, after establishing that, let's try to solve these 5 questions to see how we can do that. So, which one can we take as our first function? Remember we have the light, no? So this is the logarithmic function, inverse trigonometric, algebraic. So this is the algebraic come before the trigonometric. So we make this as our u. So remember the formula, integral u, the v is uv minus integral v du. Okay? So we're going to replace this as our original function, which is integral u, or we can say let our u be what? X. Then the v is what? Sine x, the x. We need uv. We need u, dv, and v, and du. Then du, when I differentiate x with respect to the x, is 1. Then when I integrate this function, I'll have minus cosine x. So after getting these values, I can now proceed to solve this question. Now, integral u is what? Integral x, the v, sine x, the x, which is our original question, equal to what? What is my u? My u is x. What is my v? Integrating the v. Integrating this one, I have minus sign. So I have minus cos x minus, remember I'm following the formula, minus integral v is minus cosine x dot du. Differentiating u with respect to x, I have 1. Now, what do we do next now? And simplify further. I can just abandon this side for now, the left hand side, because and say equal to what? Minus, can bring the negative sign in front, minus x cosine x minus times minus is what? Plus what? Integral of cos x. So I'm going to integrate again. Now I have minus x cosine x plus what? What's the integral of cos x? Is sine x plus c. After when you finish integrating, you must put your constant of integration, which is your plus c. Now what do I do next? I can say, okay, this should be my final answer. So we're going to take the second question now. Now, for our second question, we have integral of x cubed ln x dx. So, in the same vein, we'll have to establish what will be our u and what will be our the v. So, in the same way, this is the trigonometric function, or the logarithmic function comes first. So we have to use this as our u, because if you take this as our u, it will be hard to find the integral of this function. So that's why we use this as our u. So I can find the derivative of this function. It's easier to get the derivative, which you know is 1 over x. So the same way we have integral u dv equal to what? uv minus integral v du. So we're going to bring out the normal missing house. U will be what? Will be ln of x, because it comes first. Logarithmic function comes first. Then v is what? Taking the integral of this function. So we know it's x3 plus 1 over 3 plus 1, which is x4 over 4. So put x4 over 4. So the u is what? 1 over x. When I differentiate ln x, I get 1 over x. When I integrate 1 over x, I get ln x. Then the v is what? X cubed dx. This cubed. Okay. Now substituting these values, I have equal to what? U is what? Ln of x dot v is what? x4 over 4 minus integral of what? V is what? x4 over 4 dot du. U is dot 1 over x. So what do I do next? If I want, I can bring out this 1 over 4 outside, because it's the constant. I can say 1 over 4 ln 1 over 4, and say x4 ln x, right? 1 over 4, I'll bring it outside, then x4 ln x minus x4 divided by x, I have x3. I can bring out this 1 over 4 again, because the constant, to 1 over 4 integral of what? X3. I brought out my constant, then I can divide 1x by x4. I have x3 remaining. So I have 1 over 4 x4 ln of x minus 1 over 4. When I integrate x3, I have x4 over 4 plus c. Now, I can simplify this. I can leave the answer as my final answer, but you can simplify to make it look better. So I have 1 over 4 x4 ln x minus 4 times 4 is 16 minus x4 over 16 plus c. If I want, I can still simplify because 1 over 4 is common in both places. So I have 1 over 4 factorizing. We have x4, oh sorry, 1 over 4, 1 over 4 x4 is common. 1 over 4 x4 is common. I have ln x minus 1 over 4 plus c. So this should be our final answer. Now, we solve the next question, which is integral ln of x dx. Now, if you're still watching our videos, it means that you're enjoying what you're doing. Do not forget to subscribe to our page, follow to our channel and follow our page. So for us to solve this one, now we can say using the same integration by parts, u the v equals to uv minus integral v the u. So our u will be what? Our u has to be ln x because logarithm function comes first. Then the v should be 1 dx because what is the coefficient of the x here is 1. Then the u is 1 over x, v equals to what? X, right? If I integrate 1 with respect to the x, I'm going to have x. So substituting these values, I have u is what? Ln x. U is what? Ln x. V is what? Dot x minus integral v is what? X dot 1 over x. So I can bring out this x here. The x ln x minus x divided by x is what? 1. So integral 1 dx. Right? Now, I say x ln x minus, if I integrate 1 dx, I'm going to have x plus c. Then I can just say x is common in between. I have ln x minus 1 plus c. So when I integrate this function, I'm going to have this. So we'll go to the next question. Now, the fourth question is this. How can we solve this? The same way. Use this as our u and this as our v. So our u is x cubed. The v is sine x dx. The u equals to 3x squared. V equals to what? Minus cosine of x. So our formula is still u the v minus integral v the u, right? Now, sorry, integral u dv equals to what? uv minus integral v the u. So let's substitute equals to, what's my u? X cubed. What is my v? minus cosine of x minus integral v is minus cosine of x, the u is what? 3x squared. So let's simplify. I can bring this minus out, minus x cubed cosine x minus times minus will give me plus. I can bring out this 3 plus 3 integral of x squared cosine of x. Minus and minus plus. I'll bring out the constant. Then now this is under two functions. It has two functions, and we must integrate by parts using the same formula. So I can come here and say x cubed cosine of x, which is the same, plus 3. I can open my brackets. I can take this as my u again, which is x squared. If I integrate cosine of x, I'm going to have sine x minus, using the same formula, cosine of minus v is what? Sine x dot the u is a 2x. So when I take the integral of cos x, I'll have sine x. So by this place I'm integrating by parts again, where this is my u and this is my dv. So let's simplify. This remains the same, x cubed cos x plus 3 x squared sine x minus, can bring out this constant, 2 integral x sine x dx. Now, so I can close this bracket. This is all two functions, so I have to integrate again by parts for the third time. So I have minus x cubed cos x plus 3 into what? X squared sine x minus 2, and open brackets if I want. Take this one as u and this one as v. So u v, if I integrate sine x, I'm going to have minus cos x minus integral of minus cos x dot 1. So I can close here and close the alpha bracket. So I can now integrate the final one. So let's come here. I can say minus x cubed cosine of x plus 3 x squared sine x minus 2 x, can bring out this minus here, minus x cos x, right? Minus times minus is plus, then integral 1 times cos x is what? Cos x dx. Close this bracket, close this bracket. So we can simplify further to say minus x cubed cos x plus 3. This is x squared sine x, okay, minus 2, open bracket, minus x cos x. I integrate cos x, I'm going to have sine x plus sine x plus c. After the final integration, you put plus c. Then simplifying, I have minus x cubed cos x plus 3 x squared sine x minus times minus plus 2x cos x minus times plus minus 2 sine x plus c. Close the outer brackets. Then I have the last brackets to expand. So I have minus x cubed cos x plus 3x squared sine x plus 6x cos x plus times minus 6 sine x plus c. Is there any way we can simplify this further? We have cos sine no. So this is our final answer. So we'll move to the last question. Now for our final question, we have this x squared dx. So the same way you can say light exponential should be the last. So our u is x squared. Our the is what? Ex dx. The u is what? 2x. Our v is what? Ex. Remember, when I integrate ex, I get ex. So in the same formula, integral u dv equals to what? Uv minus integral v du. Now, equals to what's my u? X squared dot v is what? Ex minus integral v is what? Ex dot du is what? 2x. So simplifying this further, I have x squared ex minus, I can bring out the constant, 2 integral of x ex. So I have another function again, two functions, I can use by parts again. So I say x squared ex minus 2, and open bracket because I want to integrate again. My u is now x, my dv is ex minus integral of what? V is ex dot du, differentiating x is what? 1. Now, you can simplify it by saying x squared ex minus 2 x ex minus ex times 1 is ex. If I integrate ex, I have ex, close the bracket, and plus c. So I can expand these ones. How do I open the brackets? I'm going to have x squared ex minus 2 times x is 2x ex minus times minus is what? Plus 2ex plus c. So ex is common, you can take ex and factorize. I have x squared minus 2x plus 2 plus c. So this is my final answer. So these are some few questions we are able to solve. So I believe that having this formula, we will solve any problem or integration by parts easily, just following the procedure. It may look long, but it's just when we follow the process, it's very simple and easy to get. If you enjoyed this video, do not forget to subscribe to our channel, follow our pages on Facebook, TikTok and Instagram for more interesting videos. Thank you and see you in our next video. Bye.